Okay, so let's start giving this a try. What I'll do is I'll narrate. You have to know I'll never listen to this because I will find my voice highly annoying. But this is just a first introduction. For the course description, we went through all of this. We'll go to big points, which basically the idea of the scientific method. You should be able to plan an experiment in the scientific method. We'll go through the basic steps. You observe something that you're first going to want to ask questions about and dive in more in depth. Between the question of hypothesis and prediction, you're obviously going to have to make a lot of further observations or research. We no longer just accept a random question answer for your hypothesis. It has to be based on something. And usually we'll write those hypothesis and predictions together as an statement. So let's kind of start getting into all this. So, first of all, for any observations you make at any point in time, we're going to have two basic types of observations. One is a qualitative, the other is a quantitative. Now keep in mind that these two things, quantitative versus qualitative, are working with any observations that we make throughout the lab. Both of them are highly important. I expect that in your procedure itself, during your lab, you are discussing both qualitative and quantitative. Quantitative is awesome because it's numerical and it's exact. We can do statistics on it. But the qualitative is extremely important because sometimes there's things that are happening that your quantitative does not account for. Let's say you're measuring the reaction based on the height of the bubbles, but within that, when you're the type of bubbles that you might be getting, big versus small, in the qualitative, as you describe, that is a huge part. Or let's say you're doing the quantitative and something goes kind of wrong, it overflows. Well, then you're going to need the qualitative to explain that it is overflowing as part of your reaction. Okay?